Good morning, dear students. In this class, we are going to discuss nomenclature. There are some rules. These rules just you have to read 2 to 3 times. No need to by heart. They never ask these rules. Just they will give the structure. You have to write the name. They will give the name. You have to write the structure. That's it. This is the background information. These rules are for your background information to write the structures and names, right? So need not by heart all these rules. Just try to understand, read 2 to 3 times, apply these rules when you convert name to structure, structure to name. That's it. So nomenclature, first rule, positive ions are named followed by negative ions. That means in this one K4 is the positive ion, the complex is the negative ion. That's why we compared with the double salts. Salts means it contains positive ion and negative ion. So here potassium followed by this complex, right? Potassium is the positive charge, complex is the negative charge. The whole complex becomes negative charge. That's why we compared with the salts. All right. So within this potassium, potassium comes first, followed by ligand, followed by metal atom. Within the coordination sphere, within the sphere, ligands named first, followed by metal atom. So potassium, after potassium, which comes iron or cyanide. So potassium, what are the rule? First ligand comes followed by, but when you are writing structure, the metal ion comes first, ligand second. But when you write the name, first it comes ligand followed by metal atom. So ligands named first, followed by metal atom. So number of ligands, if it is ligands 2, di. Complex ligands, just I am giving examples: en, ethylene diamine, diene, diethylene triamine, triene. These are complex ligands. Other than these, all are simple ligands, right? So at this moment, number of ligands are 2. That is, if it is CN2, di. If it is complex ethylene diamine, so bis ethylene diamine. If it is En2, bis ethylene diamine. En is a complex ligand. So if it is 3, tri, tris. If it is 4, tetra, tetrakis. If it is 5, penta, pentakis. If it is 6, hexa, hexakis. Right? So simple ligands di, tri, tetra, penta, hexa. For a complex ligand, bis, tris, tetrakis, pentakis, hexakis. Right? So it is based on the number of ligands. Ligands name should be alphabetical order. Suppose if it is amine aqua or chloro bromo iodo, which one comes first? Bromo comes first, next chloro, followed by iodo. That means ligand should be named in the alphabetical order, right? So first cation followed by complex is the negative. This potassium is the positive plus negative. So first positive followed by negative. Within this sphere, ligand followed by metal atom. If the ligands are more than one, you have to follow this one. If it is more than one ligand, chloro, bromo, if it is more than one ligand, you have to follow the alphabetical order. Negative ligands add suffix O. So negative ligands, chlorine, chloride, right? Cl minus, Br minus. You should not write chloride, bromide ion, chloride ion. You should not write like that. So negative ligands add suffix O. Chloro, bromo, iodo, cyano, nitro. So you have to add O is the suffix. O is the last letter. For neutral ligands, you have to write their original names. original names. Exceptions are there. So H2O, you have to write aqua, NH3 amine, CO carbonyl, NO nitrosyl. There are examples. They have given some examples. So for ambidendate ligand, we have discussed ambidendate ligand. Both either one of the any one of those atom can donate the electron pair to metal atom. Nitro. So when you are writing in the name nitro N, you should mention the nitro N or nitro O, whether it is donating N or whether it is donating O. So when you are writing the complex name, this ligand, you have to mention nitro O or nitro N, cyano C, or generally nitro, when it is nitro, you have to mention N or O for ambidendate ligands. Suppose if the complex is negative charge. Suppose this complex is the negative charge, either like this or I told you, if the complex is like this, this one is positive, this one is negative, or the complex without ion, if the complex is negative, or like this type, when this type of complex is present in that one, you should add 8. If the complex is negative charge, negative charge is possible in two conditions. If the simple complex, they will give negative charge, that means this is a complex is negative charge, or they have given first A group element or any element with complex. If the positive charge comes followed by complex, the complex will get the negative charge, this metal atom gets the positive charge. So in either this case or this case, complex is having the negative charge. In that case, what you have to do, you have to add ATE, 8 word. That means Fe, ferrate, Sn, stannate. The metal atom name should be Fe, ferrate, Sn, stannate, silver, argentate, Pb, plumbate, Au, aurate. These words should be added in the nomenclature. If the complex is positive charge or neutral, you have to write original name. Fe means iron, Ag means silver, right? So Pb means lead, right? So Sn means stannous. You have to write their original names, right? When you have to write their original names, if the complex is positive charge, or if the complex does not have any charges, there is no charge on this one, or like complex is just like this, either this type or this type, you have to write their original name, or this type or this type, you have to add 8 word. Suppose if the geometrical isomers are possible, structural isomers, right, stereoisomers, in that one geometrical isomers, right? So you have studied isomerism. In that one, if the geometrical isomers are possible, you have to use cis and trans. They have taken one example, platinum. If the both NH3s are same side, NH3, Cl. In this case, it is a cis complex. Suppose if both are opposite side, suppose NH3 is the opposite side, chloro is opposite side. So in this one, chloro are adjacent to each other, NH3 are adjacent to each other. In this case, you have to write it as a cis complex. If the NH3 are opposite, chloro is opposite, generally you call it as trans, right? Oxidation number of the metal atom should be written in Roman parentheses. That means if the oxidation number is 1, you have to write it in the Roman number, right? So that is the meaning. For bridged ligands, you have to write it in the mu letter. for bridged ligands. These are the some nomenclature points. You need not by heart all these nomenclature points. Just this is the background information, right? Need not by heart. Just read 2 to 3 times, right? Apply these rules when it converted into structure to name to structure. A quick revision of these points. So what is the first point? Positive charge followed by negative charge. That means potassium followed by complex. So I am writing one example, K4 FeCN6, right? This one followed by complex. That is the first one. Second one, you have to write ligand followed by metal atom. Alright. So then take ligand. If the ligand is more than 1, 2, 3, 4, 5, 6, for simple di, tri, tetra, penta, for complex base trees, like that. If the ligand is negative ligand, add O. If the ligand is neutral, just write original name. If the ligand is negative, add is the O is the suffix. Ligand should be in the alphabetical order. Alphabetical order. Ligand, you have to write it in the which order? Alphabetical order. Right? Alphabetical order. For ambidendate ligands, right? You have to mention which atom is done. Nitro N, nitro O. For bridged ligands, you have to use the mu letter, right? These are related to ligands. Ligand, you have to follow alphabetical order. If it is more than 1, you have to follow this one. If this negative ligand, you have to add O. If it is a neutral ligand, you should write original name. If it is ambidendate ligand, you have to write it which atom is donating. If it is bridged ligand, you have to add mu word. This is related to ligand. Clear? Slowly we are coming, this one followed by ligand, then we are coming to metal atom. If the complex is negative, or if like this, Cn like this is positive, this one is complex is negative. In this case, the complex is written, the metal atom added suffix 8 suffix should be added in this one. If the complex is positive, or if the complex is neutral, 8 ion, ferrate followed by oxidation number ion. Right. So complex is positive, complex is neutral, write their original name, metal original name, right? So this is related to metal atom. So after metal atom, oxidation number, you have to write the oxidation number after the metal atom. Ferrate 3 ion. If it is negative, you have to write the ion. If it is neutral, you should not write iron 3. Suppose oxidation number should be written Roman number. Suppose ferrate, I am writing one example, ferrate 3 ion. In this case, iron 3. You should write iron. That is the difference between, if the oxidation number, if the complex is negative, then you have to add 8 suffix. Oxidation number should be written as a, right, after Roman number. Oxidation number should written as a Roman parenthesis, that is ferrate 3, it is ion, that's why you are writing ion. It is positive charge, you have to write iron 3. If it is neutral, you have to write iron 3. That's it. Okay. So what is the next one? It is related to this one. These are the related to metal atom and complex. These are related to ligand. Right? So if the complex is, if there is a possibility of geometrical isomers, you have to write it cis and trans. You have to write the cis and trans. These are the rules. We will take the example, you will understand very clearly. So the first one, what is the first one? Potassium, right. Followed by which one? Negative, ligand. How many ligands? 6 ligand. Potassium hexacyano. This one is positive charge, complex is negative charge. Ferrate. So what is the oxidation number? This one is a +4. This one is a +4. This one is a -6. What is the X oxidation number? What is the X oxidation number? Iron oxidation number 2. Ferrate 2. Right? So that is enough. So what is potassium? Potassium hexacyano. Potassium is a plus, complex is a negative. That's why iron becomes ferrate. This one is -6. This one is +3. So iron becomes, what is the X? X is equal to 3. Ferrate 3. Ferrate 3 means this one. Ferrate 2 means this one. Alright. First you have to write the line. After this one, after complex, this is Cl3. You should not write Cl3. This is a negative charge. Right? So amine aqua. Triaqua. So you should not consider T is the first. You should consider A is the first. Triamine. Triaqua. All are small letters. Triamine. Triaqua. Right? So this one is a positive, this one is a negative, right? This NaCl, Na plus Cl minus, just like this one is a positive one, this one is a negative one. So in this one, chromium should be chromium only. If the complex is positive, chromium should be chromium only. So chromium. This one is neutral, this one is a neutral. So this one is a -3. So what is the chromium oxidation 3? Oxidation state +3. Chromium 3. After this one, which one is the negative charge? Chloride. So chromium 3, chloride. Right? So this one is a positive, this complex is a positive, this complex is negative. You have to consider that one. Diamine argentate. So in diamine, this one is -2. -2 divided into 2. -2 charges belongs to both two. So diamine, what is the name? Diamine. Silver. This one is a positive charge. That's why metal becomes silver. Silver 1. Diamine silver 1. dicyanoargentate. This one is a negative complex, this one is a positive complex. So this charge is divided into two complexes. -2 becomes -1 and -1 argentate 1. So some typical components they have given in the textbook. Right? We will take some more example, you will understand very clearly. Right. These examples they have given in the textbook. Right. So first one, if you see first one, amine chloronitro. Nitro, it is if they have given N first, so it is ambidendate ligand. You have to write nitrogen. They have given N. If they have given ONO, that means you have to write it as a nitro O. Right. So which one is there is no positive charge. This complex is neutral because there is no charge on the complex. So platinum becomes platinum only. Right. So in these three are ligands. Amine, chloro, nitro is three ligands. What you have to do? You have to follow the alphabetical order. So what is diamine, chloronitro, right? Diamine, chloro, nitro, N comes first. So platinum, N, platinum. So this one is the amine is the neutral ligand, chloride is the negative one, nitro is the negative one. What is the oxidation state of platinum? Platinum oxidation state is the 2. Platinate. Why it is not written as a platinate? Because the complex is neutral complex. That's why you are writing as its original name, platinum. Right? Right. In this case, potassium comes first. Potassium. C2O4 oxalato. You have bidendate ligand. Right? So trioxalato. Potassium. Trioxalato. So this is the trioxalato. What is the oxidation state? C2O4 minus 2. So what is the oxidation state? For each C2O4 minus 2, for 3 it is 6. Potassium is the plus 3. So what is the chromium oxidation state? What is the chromium oxidation state? What is the chromium oxidation state? Plus 3. Trioxalato, it is a positive charge, complex becomes negative charge. Chromate, trioxalato, chromate 3. Why it is chromate? Why it is not chromium? Because potassium is a plus. When it is a positive charge, the complex becomes a negative charge. In that case, chromium becomes chromate. Right. So, ethylene diamine. So, dichloro, I told you ethylene diamine, you have to write bis. Dichloro, bis, ethylene diamine, ethylene diamine, or you can write it as a ethane 1,2-diamine. Ethane 1,2-diamine. Either you have to write ethylene diamine or ethane 1,2-diamine, bis ethylene diamine. This complex is positive, NaCl. This complex is positive, chloride is negative. So positive complex you have to write it as a cobalt. Cobalt only. Cobalt. So what is the charge? This one is a -1, this one is a -2. Cobalt becomes, what is the cobalt becomes? Cobalt becomes plus 3. Cobalt 3 chloride. Cobalt 3 chloride. So you need to practice, then only you will understand very well. Otherwise the nomenclature will be difficult. For this one, you should know what is ligand classification, and their oxidation number. Right. This one also, complex is a positive, Cl is the negative. Right. So amine carbonate, pentaamine. How many amines? 5 amines. So pentaamine, only single carbonato. Right. So pentaamine carbonato. Carbonato is the negative -2 charge, Cl is the -1, amine is the neutral, so cobalt is the X. What is the oxidation of cobalt? Cobalt +3. Pentaamine carbonato. So this one is the complex, is a positive charge Cl. This is just like NaCl. This is like a NaCl, Na plus Cl minus. Right? This is also just like Na plus Cl minus. Complex is having the positive charge, Cl minus is the negative charge. Right? So pentaamine carbonato cobalt, cobaltate another, cobalt 3 chloride, cobalt 3 chloride. Right. So what is this one? Mercury, this one is positive, the complex becomes negative. This one is positive, the complex becomes negative, cobaltate. So tetrathiocyanO, which one? Mercury tetrathiocyanO, cobaltate. This one is -4, right? This one is +1. So what is the X? Cobaltate 3. Cobaltate 3. Right?